74,000 years ago, humanity almost disappeared, not because of a war, not because of a plague, not because of a meteor, because of a mountain. And what happened in the years after that single event explains something strange about every human being alive today. Why you and I, no matter where we come from, are genetically almost the same person. Let's go back to the island of Sumatra, in what is now Indonesia. Beneath the jungle sat a supervolcano called Toba. It had been dormant for hundreds of thousands of years, quietly building pressure underground, completely unnoticed by the small bands of humans living thousands of kilometers away in Africa. Then, one day, it erupted. This wasn't a normal volcanic eruption. This was one of the largest explosive events in the history of our planet, the most violent eruption of the last 2 million years. To put it in perspective, it was thousands of times more powerful than Mount St. Helens, and hundreds of times larger than any eruption a human being has witnessed in recorded history. It ejected an estimated 2,800 cubic kilometers of material into the sky. For comparison, that's enough to bury an entire country under meters of ash. The explosion was so massive that ash fell across South Asia, blanketing the ground more than 6 meters deep in some regions close to the volcano. Layers of Toba ash have been found as far away as East Africa and the Arabian Peninsula, proof of just how far this single eruption reached. But the ash falling from the sky wasn't even the biggest problem. The real danger came from what happened next, in the atmosphere. The eruption threw enormous quantities of sulfur dioxide high into the stratosphere. Once up there, it turned into a fine aerosol haze that spread around the entire planet, reflecting sunlight back into space before it could ever reach the ground. The sun stopped warming the Earth the way it used to. Global temperatures crashed. Some researchers estimate a drop of several degrees Celsius worldwide, and in some regions, even more. This period is often called a volcanic winter, and some models suggest the darkened, cooled skies may have lasted the better part of a decade, with effects on climate lingering for years beyond that. Now imagine you're a human being living through this. You don't know what a volcano is. You don't know what's happening on the other side of the world. All you know is that the sky looks wrong, the seasons stop making sense, and the animals and plants your entire survival depends on are dying around you. Forests that had taken thousands of years to grow began to collapse. Grasslands turned to dust. The plants that herbivores depended on disappeared, and the herbivores that humans hunted followed soon after. Food, which had never been guaranteed even in good times, became almost impossible to find. This is where the story of Toba connects to something scientists discovered much later, by looking not at rocks or ash layers, but at our own DNA. In the 1990s, geneticists studying human populations around the world noticed something strange. Compared to other primates, humans have remarkably little genetic diversity. If you compared the DNA of 2 chimpanzees from neighboring valleys in the Congo, you'd likely find more genetic variation between them than you would between a human being from Tokyo and a human being from Peru. For a species of 8 billion individuals spread across every continent, that shouldn't make sense. Unless, at some point in our history, our population had been reduced to a tiny fraction of what it is today. This idea became known as the Toba catastrophe theory, and it proposes exactly that in the aftermath of the eruption, the global human population may have crashed to somewhere between just a few thousand and 10,000 breeding individuals. Some estimates go even lower. For a brief window in our history, our entire species may have been rarer than gorillas are today, rarer than tigers, genuinely, dangerously close to blinking out of existence entirely. Think about what that actually means. Every single human being alive right now, every person you've ever met, every historical figure, every civilization that has ever existed, all of it descends from that one small surviving population. We are not the descendants of a thriving, spread-out species that had a rough few centuries. We are the descendants of survivors who made it through what may have been the closest call in the entire history of our species. Not every scientist agrees on how severe the bottleneck really was. This is still debated in paleoanthropology, and some newer archaeological evidence suggests certain human populations may have kept thriving even during this period. But almost everyone agrees on one thing. Something happened around this time that reshaped the human gene pool, and Toba remains one of the leading explanations. And here's the detail that almost nobody talks about. The part of the story,
Not every group of humans suffered equally during this period. Along the southern coast of what is now South Africa, archaeologists have uncovered something remarkable at sites like Pinnacle Point and Blombos Cave. Evidence shows that humans there weren't just surviving the volcanic winter. In some ways, they may have been thriving. These coastal groups had access to something inland populations didn't: the ocean. While grasslands were dying and herds of game were disappearing across the interior, the sea kept producing food almost regardless of what was happening to the climate above it. Archaeologists have found enormous deposits of shellfish remains at these sites, mussels, limpets, and other marine life that could be gathered reliably, season after season, without depending on rainfall or healthy vegetation. Some researchers believe these coastal refuges may have been among the very few places on Earth where humans reliably rode out the worst years of the volcanic winter. In other words, the difference between a lineage that continued and a lineage that ended may have come down to something as simple as living near a beach. And there's something almost poetic hiding in these same caves. Alongside the shellfish remains, archaeologists at Blombos Cave found pieces of ochre engraved with deliberate, abstract cross-hatched patterns, among the oldest known examples of symbolic human behavior anywhere in the world. Shell beads, pierced and strung, likely worn as jewelry; tiny, precisely made stone tools requiring real planning and skill to produce. In other words, the same small groups of humans who survived the aftermath of one of the largest volcanic eruptions in Earth's history by eating shellfish on a beach in Africa may also be among the very first humans we know of who were starting to think, express, and create in ways we would fully recognize today. This wasn't the only time our species came close to the edge either. Some researchers point to other, smaller population squeezes throughout human prehistory, moments driven by climate shifts, migrations into new and unforgiving environments, or simple bad luck across many generations. Toba may be the most dramatic example we have evidence for, but the deeper lesson is the same each time. Our existence today was never guaranteed. So the next time someone tells you that humanity has always been destined for dominance, that our success as a species was somehow inevitable, remember this: 74,000 years ago, we weren't dominant. We weren't spread across the globe. We were a few thousand people, maybe fewer, huddled on a strip of coastline, eating shellfish under a darkened sky, one bad season away from disappearing forever. Everything that came after, every city, every language, every book, every person you've ever loved, exists because a small group of humans on a beach in Africa managed to hold on just a little longer than the world tried to make possible. We didn't just survive. We came back from the edge of extinction to fill an entire planet. And that might be the most human story of all.